Alright, welcome back. This is lecture number 4 of Computer Concepts. I believe we left off at storage devices. So we'll go ahead and pick up where we left off. Storage devices. This is a rough timeline of different types of storage devices. We won't talk about all of them. But there are some notable ones on here we'll mention. Now, what a storage device allows you to do is it allows you to store data so you can access it later. So if you're writing a paper, you can save it, open it later. If you're playing a game, you can save it and come back to where you left off. That's the purpose of storing your data, or these storage devices in general. So you can save your stuff and still be able to use it. We mentioned RAM. Well, that can't save anything. It can only hold what you're currently working on. So you need some long-term place to store it that won't disappear when you turn off the power. Now, before we get into the actual devices, we need to go over some of the terminology so you can kind of get an idea about the size of things. So I'm going to try to make this as plain and simple as possible. Bit. That's the smallest form of measurement as far as data goes. This is basically just a 0 or a 1, on or off. That's all a bit basically is. Now in nibble, you will generally not hear that used very much, but it's 4 bits. Now if we equate that to letters, and I like to equate these to letters because a letter is easily identifiable. You know what a letter is. A, B, even 5 is technically a letter as far as the computer is concerned. One single character. But this is roughly half a letter. A byte is one whole letter. So if you went to Word, type the letter A. That's a byte of information. And your general word is going to be somewhere between 2 to 8 letters. Now, the first thing most people do hear about, kilobyte. At this point, this is 1024 bytes. If a byte's a letter, then 1024 bytes would be about 1,000 letters. I'm going to round down, but you got about 1,000 letters here. So if I went to Word, typed 1,000 letters, I'd have a kilobyte of information. Now every time we move up, we're going to go up by a magnitude of 1,000, basically. So 1,000 times the previous is our next unit of measurement. So a megabyte is 1,000 or so kilobytes. So in that case, that means that if we typed 1,000,000 letters into a document, we'd have a megabyte of information. Likewise, if you typed a gigabyte, well, now we're looking at billions of letters. Trillions of letters. And even more and even more. You can kind of see it's a fairly substantial amount of information. Now, that's a lot of letters. And to put it in a context, in your standard 250-page book, there's somewhere between 400,000 and 500,000 characters. And of course, a 500-page book would be, about 1,000,000. A megabyte of information is about 1,000,000 characters. So I could store 2, fairly standard books in a megabyte of information. 1 at the least. Now, of course, if you think, well, a gigabyte, that's about 1 to 2,000 books. And then, of course, a terabyte would be, tens or hundreds of thousands. And no sense even mentioning petabytes. I mean, you could have a small library with some of that information. I could easily fit several hundred novels into some of those. And that just gives you an idea of how much information that actually is. Now, we'll talk about our first little bit of a storage device here. This is a punch card. Now, it's still used in some contexts. In some places, some election actually still use punch cards and stuff like this to vote and things like that. Kind of ridiculous. You may have heard about hanging chads and various other things years ago in Florida. It's always Florida. Whoop, there we go. But basically, what this is these little holes are punched in here in specific places. And when the machine reads these holes, it's like, oh, this represents the letter A, B, C, 5, 6, so on and so on. So it can read these little holes and figure out what information this card is representing. Years and years ago, people used to actually have to use punch cards to write programs and do things like that in the computer science departments. I missed all that, fortunately. But I've heard stories of horrific things where they went to the computer center, wrote their program, and it punched out, 200 cards that basically was their program. And they had to go bring all those cards to the supercomputer center, plug in each one individually, have it read it, and then the program would run. Now, if there's any kind of screw-up or mistake, well, they had to go back and repunch all the cards and do it all over again. If something horrible happened and they happened to drop the cards and get them out of order, they would have to start all over again. So it's not a very efficient way to store information. Now, believe it or not, you are still using something similar to this now, probably. If you're in school, you've probably seen one of these things here, a Scantron. It is the exact same technology. In fact, if you look at it side by side, you can see it's very much the same. You blacken a little circle, the machine reads it, and that's how it knows what information is what. In this case, it grades. It says that is that, but it's supposed to be this, so you get things that are missed and things that are not. Now, most of you should know this, magnetic tape. By the sound of it, you're probably going to be thinking, I'm not sure about that. But magnetic tape, you see these little spools in the picture. They have basically film on it, magnetic tape. And it spools from one spool to the other. And while it's going from one side to the other, it's recording information on it. Now, they're still used in long-term backup. And they use magnetic particles to store data and information, which is good and bad at the same time. The reason this is still used in some major data centers today is mostly because, well, you can store these things for half a century if you're stored correctly. They actually have very good shelf life. And if you're just storing information as backups to potentially use in the future, maybe, but probably not, this is a pretty decent enough way and doesn't cost so much money to do it, especially at a big data center. Now, of course, it has its problems. Like I said, it uses magnetic particles. There's been more than one instance of a really angry employee just decided, as he's walking out the door, to throw magnets past these things. And since, of course, they use magnetic particles, you can imagine what happens. Well, even though you may not think you know about magnetic tape, you've actually used it quite a bit, most likely. Even if you're relatively young, you've probably still seen it in the form of this, a cassette tape. Now, a cassette tape is just like I described. You've got one spool here, one there. And then, as you play it, it reads it down at the bottom, and one side spools over to the other. So you're reading it as it's going across. Now, cassette tape can store about 660 kilobytes of information on each side, a 90-minute tape. This is one of the reasons I gave you a little primer about sizes, so you can kind of have a rough idea about what that means. So 660 kilobytes, that's a fair bit of letters. You'd have to write quite a few papers to equal that. But still, this is all audio data that's stored. And if you haven't seen that, you've probably seen this. A VHS tape, a VCR. And you'll notice that it's got the films sticking out of it too. It's the same exact technology as this. In fact, we'll still use this same technology in a couple of other storage devices. Now, this 90-minute video can store about 650 to 900 megabytes of information. Now, it's not perfect. It does have problems. If anyone's ever had an old VHS tape and they've watched it several times, maybe more than several times, you may have noticed that it does wear a little bit. You get crinkles in the screen, or things blur off for a second or two. These things don't last forever. So it's not the best way to store information. And in fact, there are better things that have come about that have replaced all these that we'll talk about later. Now, the major problems with magnetic tape. It's not incredibly fast. It's fairly slow. Now, the major reason for that is you got to go through everything else to get to the part that you want. If anyone ever remembered the cassette and VCR tapes I just talked about, if you wanted to get to a particular song or a particular point in the movie, you had to fast forward through everything to get there. So I have to go through everything prior to get to the part that I want. And usually that involves us fast forwarding, stop, let's check, nope, fast forward, stop, let's check, oh, we went too far, and then you go back and you get just the part that you want. So it wasn't very efficient. Now, the next data storage device would be your floppy disk. And as you can see, it has a couple of different incarnations here. Throughout the years, it shrunk a little bit. They were quite large in the beginning. Now, a floppy disk could store anywhere from 80 kilobytes up to 1.44 megabytes of data. These were traditionally used to store programs and documents and things like that and move them from computer to computer. This was one of the first truly, mobile storage devices. You could put it in a computer, take it out, and put it in another computer. That was something that really you didn't have much of at the time. It's one of the big things that you always see with 80s computers, the floppy disks. And of course floppy disks hung around for quite a while. They tried to keep them around even further. I think they even got the floppy disk up to like a few hundred megabytes of storage, like 1, 2, 3, something like that. But the major issue with this is it's not incredibly fast. It actually uses the same technology as the tape drive. This right here is a big circle actually that spins around, and it's a circle of magnetic tape, magnetic film basically. And as this thing spins, it reads and writes onto that magnetic tape. Now the first floppy was actually floppy. You could actually wiggle it in your hand and have it flop back and forth. And then we got less floppy as time went on. And then we had this hard diskette, that you see later. Now, the thing that killed, well, the floppy disk and, of course, the cassette tape would be your compact disc. Believe it or not, this thing was actually invented in the 1970s. It was the size of a record, and it was kind of expensive to make at the time, until, we got better with plastics and, mass producing things, and shrunk this down a little bit. But this can hold up to 700 megabytes of data. You use lasers to read and write on the surface. How this works is a laser hits the surface of the disk and burns a little kind of pit into it. Now when you're reading it, after it's already been burned with information, the laser hits the surface and reflects back. And it can see where the pits are and where it isn't. And this is how it interprets its data. So it runs across and, that's a Word file, and then it translates that data and opens it up. Now, of course, this killed the cassette tape. Because, I know everyone probably misses fast forwarding to get to their favorite song. But the bonus about a CD is, if I wanted a song, I just point the laser where it happens to be located. If my song is right here on this ring, this track, then I point the laser there and it goes and I read it. If it's on this one, then I just point the laser there and it plays the song. It's far more efficient, and actually it's less expensive to make overall. Now, types of CDs. You have CD-ROM, which is read-only. You can only look at it, basically. This is something you'd buy at a store. And take it out of the box, put it in your computer. You can't change it in any way. CD-R is a recordable disc. You can write to it once. So you can burn into that CD one time, and then you're done. All you can do is look at it. A CD-rewritable is a rewritable disc where you can write to as many times as you want, at least until it fails. The more you write to it, eventually it's going to start degrading a little bit, because there's only so much you can burn into the surface before well, the disc isn't any good anymore. But they can still last quite a while. Now, the next one would be DVD, digital video disc. This can hold up to 2 to 8 gigabytes of data, depending on the format. And you see it's significantly more than your CD. Also uses lasers to read and write. Pew! So as you can see, it's the same thing as the previous one. This killed the VHS, which for the exact same reason as the cassette tape. I can point to wherever I want to go in a movie and it goes there. I don't have to fast forward, you don't have to rewind. And once DVDs came about, well, there wasn't any more need for a VHS. These were smaller, more compact, considerably cheaper to make, and easier to mass produce. So you could throw out tons of these. Of course, this is also the start of the end of your favorite movie stores. Video stores and stuff used to be a thing in the past where you go there and rent movies and things like that. And now it's all DVD and digital format, which pretty much destroyed that entire industry. Now, you have the same types of DVDs. You have your ROM, your recordable, and of course your rewritable as well. Now this completely replaced VHS. They just tossed those aside. Every time a new format comes out, if it's universally better, then the industry will pretty much go with that. Occasionally you'll have some competing formats, which we actually had in CD and DVD, some smaller differences, but they ended up coming together and making one major format that everyone uses. Now, Blu-ray, high definition video disc. This can hold anywhere from 25 gigabytes to 100 gigabytes of data. If you remember the CD, 2 gigabytes, maybe 8. That's significantly more information. Now, this still uses lasers to read and write, as you can see. It killed the DVD this time. Although, honestly, it wasn't completely without a fight. This is where it gets a little more interesting. Blu-ray was not the only thing that came about, which I think we're about out of time, actually a little bit more than I intended. So we'll actually stop right here, and we'll continue the discussion on Blu-ray in the next video.